All right, so number 6 here about the chameleon and capturing an insect. We're given the length its tongue can extend and the amount of time, and we're asked to find the tongue's acceleration, assuming a constant acceleration. So, it's a written Y. So so I'm going to start off with, let's see, acceleration is related to displacement and time. Starts from rest and accelerates the whole time it is moving. And let's see, is there anything else? I think that's about it for that I would need for the Y, because I mean this one's pretty straightforward. So let's see, this will be in A block, date 2, problem 1. So equation-wise, I'm looking for something that relates velocity and acceleration and displacement, and I find it right down here. So let me grab my snipping tool. There we go. Now, problem here though is I don't know acceleration, I don't know v final. I do know v initial, it's 0. But I do know displacement. But I guess that one wouldn't be a good one to know because I don't know two things. So I couldn't use that just directly. So let's get rid of that one. And we can see if I have another option that relates acceleration and displacement and maybe brings time into it. And I do, it's my general one there. So let's grab that one instead. So let's see. I'm going to assume in my case that the tongue starts at 0 in position and also 0 in initial velocity. They told me my time, so I have that. And they told me my final location. So the only thing I'm left with is acceleration. Plug it in and I'm done. Now, of course, I need to be careful of units, right? And because they ask for the value in meters per second squared. They give me my time in seconds, so that works. But they give me my final location in centimeters, so I have to do that tricky conversion from centimeters to meters. And so be careful of that. Yeah, that'll do it on that one. Questions? Excellent. All right, so number 10, we've got these lava bombs going up, and we know that as soon as they leave the volcano, they're actually in free fall. So the only thing acting on them is gravity. So that would be good to note. The lava bums are in free fall, thus accelerating downwards at G. And find the time to rise. The time to rise to maximum height is this, and the acceleration is this. What is the initial speed? So they must stop at the maximum height, or they would go higher. And that would make it not the maximum. The faster their initial speed, the higher they will go, since a constant acceleration. Yeah, I think that's it. Questions on the why? You guys know you have this document, right? I sent it to you on Friday. So if you want to pull it up on your screen, you can. Alright. Let's do this thing then. So, I know the time. I know some things about the acceleration. I know some things about the speed, and I want to know more things about the speed. So a relationship that relates velocity and time and acceleration is this one. That seems like a good place to start. Let's see. I know my final velocity, that's 0, because it gets to the top. They tell me that. I don't know my initial. I know this. Is the acceleration positive or negative? Which direction does it go? It's going down. Are we going to call down negative? Sure, we can. So, and then I'm given the time. Yay! Love it when I get one equation and I know everything but one thing. Then it's just algebra, which that makes life better. All right, and that's it on that one. Let me know if you need help individually with it. All right, so 19. Oh, this is like this is the lab that you guys did, right? The mini lab? Power up the stairs? So, and they want the answer in horsepower. Alright. So, our Y for this one is an energy bar graph, just like it'll be on that test for Friday. And I'm going to add in PE graph. Oops, made that a little bit too short. Alright, so at the beginning, I'm assuming I'm standing still. No kinetic energy, I'm at the bottom of the stairs. Then I'm going to do some work. Let's say this much work as I go up the stairs. Where's my... Oh, there it is. And that will actually become gravitational potential energy is the way I'm going to look at it when I get up the top. I'll be stopped again, so no kinetic energy. So, yeah. I think that's my complete needed bar graph. Probably wouldn't be bad to add in here, that I know that power is the rate that you're doing energy work and things like that, but not required unless there were some lines. So they tell me about the mass. I'm assuming I'm on Earth. They tell me about the time. They tell me about the height. And I'm looking at PE grav. So I probably would be good to have my power equation here. And in case, because I need it, because I know that the work I do is going into gravitational potential energy. Grab that one. So, so it asks me about the power, and it also tells me 746 watts equals 1 horsepower. So I think I'll make a note of that someplace. 1 horsepower. 746 watts. So the power that I do, I'm looking at this form of it, the change in energy. And as I see from my bar graph, my energy is going from work that I do to gravitational potential energy. So it's doing this work that I'm creating power, yeah, that's a good way to put it. And I know it's going into PE grav, so I get my change in energy is going from no energy to PE grav. So it's just the PE grav final. So this would be my PE grav final, and minus 0, because remember change is always final minus initial, delta T. So my PE grav, I have mg, which I know, h, which I know, delta time, which I know, and there we go. Now the only thing I'll have left to do at the end is I'll get an answer down here, and because I'm going to use kilograms here, and newtons per kilogram here, and meters here, and seconds here, I'm going to get an answer in watts, which is also, of course, a joule per second. And then all I'll need to do is convert it from watts to horsepower. So then I'll just need to do that little conversion and get it in horsepower. Which of those is going to be a bigger number, the watts number or the horsepower number? The watts number. Watts number. So just maybe as a side note, remember thinking about this, this will be larger than this. Because I know conversions can be tricky, especially on a Monday morning. So, all right, give that a try. let me know if you need help. Watch your units, and then let me know what you need individually. There weren't any really others on the survey that stood out.